Yeah, hi and welcome to the screencast. Unfortunately, the screencast from the lecture had a problem. So what I'm going to do is I'm going to develop everything we did for hands-on one more time to give you an idea of how you develop a GUI and how you develop the address parser. So let's start by creating a new project, and I call it BFST18 web lecture. And as in class, we are going to start with one source file, and that source file is our task that we had from Learned, or what is included there. So what we want to do in the next minutes is we want to write an address parser, but it's actually twofold. So first, we want an address parser to pass user text input as an address. Yeah, and we come up with a very rudimentary solution to that. And then we also want a model view controller-based application where a user can actually input an address, and the address is then displayed in a nice way. Okay, and where are we going to start? We start with this address.java file here. So let's just save that one in our newly created directory. Like that. Let's go into do some coding here. And let's always keep in mind, like, what is the actual task here. Okay, let's start IntelliJ. And we have to import a new project because we already have this Java file in there. So let's go to desktop, and this is the web lecture. Okay, and that's how we're going to start. So we have one file, address.java. What we see here is that an address is going to hold a street, a house, a floor, a site, postcode, and city. All of them are strings. But the construct is private, so we don't want people to create an address by providing all of these information. What we want is we want them to call this method public static address parse, which gets a string and returns an address. And we build this address from that string by using regular expressions. We're going to talk about that a bit later on. And we have this builder class, which is part of a builder pattern. So if you look for builder pattern, you get a nice Wikipedia entry that explains to you, like, when do you use this pattern. Okay. What we all want to do first we create a basic skeleton. We create a user interface using the model view control approach. And in the second part, we actually build the address parser using regular expressions. Let's start with the first part. Let's go back to the assignment. So what we should do is we should create 3 classes: main.java, model.java, view.java. Main contains the main method, nothing else. Model.java stores all the entered addresses, and view.java displays the entered addresses in the window, and maybe it allows the user to enter new text, but I think we should aim for that we have it interactive. So let's create 3 new classes. And so there's a model, there's a view, and there is a main method. If we think about model view controller, what we have in mind is the following picture: that there is a user that interacts with the controller. The controller modifies the model. The view and the model, they have some interaction. So the view reads data from the model that it then displays. So this is seen by the user. but the model also notifies the view about changes. Okay, so the view visualizes the content of the model, contains the UI elements. Let's build that one first. So this one should have a main method. All we want to do is we want to start our user interface from that. And this can be done using Swing utilities .invoke later. And all we want to do is we want to create a new view that is then displayed to the user. Like this. And now let's build a basic user interface. You have seen how to build user interfaces in your Grundlehre Programmering class in the first semester as well. So this is going to be a bit quicker now. So we go to our view, and our user interface consists of a main window, that's a JFrame in Swing. It consists of a text field, that's where you want the user to input addresses, and there should be a text area. This is where we see the output. Okay, so if we go back here, so there is an interface that lets the user input an address and should display the address. And the idea is that the user inputs the address here in this text field, and the user output is provided, and the address output is provided in this text area. Okay. In class I did this a bit slower, but here I'm just going to create the basic UI by scratch, from scratch, a bit faster. So we want a new JFrame as our window. The title should be something like address viewer. We want to set a default close operation. If we click on the X to close the window, we actually want it to exit when somebody presses that. And we need a layout manager. And this is going to be a border layout. This is something that you have learned in your Grundlehre Programmering course as well. And if you Google for it, you see like this is the border layout. It has certain borders, and you can assign UI elements to these regions. So what we will say, for example, there's a user input, and this user input should go to the north, so it will be displayed here. And we should also set some preferred size here. Otherwise it's going to be empty in the beginning, and you just have to you always have to resize it when it starts up. Let's say 500 pixels wide and 30 pixels high in height. Okay, and let's just move these things a little bit around. There's user output. That's a new text area. We should also set its preferred size. Let's say same width, a bit higher. And it's a JText area. Okay, and this is the user output. This one should go to the center of the screen, directly in here. Since we don't have west and east, this stretches the whole program area, except from the user input. Also, something we don't want is that people can write in that part, so we set editable to be false. Then we add these two components. We have to say window manager, layout manager, please pack these windows together according to their preferred size, according to the layout. And then we say set whisper true. Okay, let's see how far we got. So I go to main and I open this main method. Okay, and we see an input text here, we see a text area here. I can redraw those, I can input text here. Okay, but nothing happens to this text, of course, for now. So now, what do we do next? So now we have the UI in place. That's basically our view part of the model view controller. So let's do the model next. The model is just stores all the data, and data here is just a little list of addresses. Like that. And we have to import the list, and we should set it to private because only the model should be able to modify these addresses. Okay. We say it's a new array list in the constructor, and the model should be able to add, or through the model we should be able to add a new address. And all we do is call address system add this new address A. For debugging reason, let's have a printout statement here as well. Something like that. That's our model. How do we populate the model? Well, if we really think about it, this is where the controller comes into play. So the user interacts with the controller modifies the model. For the next hand-on sessions, we really are going to use this controller. But for this, for the purpose of the first hands-on session, the controller is really only minimal because it's only this user input. So let's do this just in this view. So what we want to do is we want to react to user input. And how we do this is we provide an action listener. Did somebody press, for example, the return key? So there's an action A. And what do we do with this action A? Well, we disregard it. We are interested in what was typed in there, and we want to build an address from that. Okay. Now what we see is, this is actually the controller part here. The view doesn't know about the model yet. And we actually didn't instantiate a model to begin with. So let's create a model and pass this to our view. Then the view here also needs a model, and it needs to store this model. Okay, and first thing we are going to do is we say the model is M. Now we can say when we see an action on the user input, we call model.add. Then we want to create a new address, and this is done by calling address.parse, and the string that we want to provide in here to build the address from, that is whatever is written in the user input. So we say user input.getText. Okay, and afterwards, what we really should do is we should make sure that this is cleared as well. So if I press enter here, the user expects me that all the input tick goes away. So let's do this as well. So we say user input.setText. To the empty string. Okay, so this is going to allow people to input something, and then we actually put this address into the model. Let's just try that out. So we say this, and we see that there was an address added. You see there is no toString method yet in address.java. That's the default object implementation of toString, saying class name add hashcode. So what is missing currently is that the model notifies the view, and the view then reads the model. There are many ways of doing this, but what we want to do is we want to make it as generic and independent as possible. So what comes in handy here is the so-called observer pattern, where an object is observable by an observer. So we can just say the model extends observable. And that means now there are some new methods added. So if we ask here model dot, then we see you can notify observers, we can add observers, count observers, and all of these things. Okay, so what we want to do is that we want to that the view now observes our model. We do this by saying that the view implements observable. IntelliJ is going to complain because implements observer. IntelliJ is going to complain because if you implement observer, you have to at least implement the update method. And yeah, you always see like there are some key presses that I do, and they come shortly in the bottom of the screen to allow you to see which kind of shortcuts I pressed here. So we want to implement these methods, and we want to implement the update method. So the idea now is that the model says that something changed. So we have to call set changed on the observable object, and then notifies all of its observers from the change. Okay, let's go back to the view. So this will then allow us to call update. Now we have to implement this update method. What we want to do is we want to read from the model. So what we actually want to write is something, or the idea is that everything should be put into the user output. So what we want to do eventually is something like user output.setText long string of addresses. Okay, we have to build up this long string. If we want to build a string and we don't know how many elements or how long the string is going to be, but it's possibly very, very long, then you usually use a string builder. That's something that we discussed in class. So this allows you to build long strings much more efficient than if you were just to concatenate single strings all the time, because this concatenation is actually very inefficient in Java, because strings are immutable. And that means Java always has to create copies and new strings if you want to concatenate two strings. This is going to be very memory inefficient. So what we want to do now is we want to use the string builder, which is in the beginning it just holds an empty string, and we would like to do something like this. For all the addresses A that I see in the model, I want to say that I want to append the string representation of the address, and let's say I also want to append these two new lines here. And then this final set text down here would just be as toString. But of course we see a problem, like this doesn't make sense to Java right now. Like address A and model. How can we iterate over model? So this is our model, and of course in here it would be easiest to give access to this list here. But then again, the model should be the only one that changes data. So we really don't want to give access to this list of addresses. What we can do to support these for each loops here, this kind of iteration, is we can tell the model, well, you're actually iterable, and you are an iterator over an address. Then IntelliJ is going to complain because you have to implement some methods. The iterator for each and splitterator. The iterator is the one that we have to implement here. And what we're going to return is just the iterator over these addresses. So now this makes sense to Java. So the model provides an iterator over addresses, so this is perfectly fine to say. Okay, let's give that one a try. So we have our address viewer here. We can type in ASDF, and there is an address added, but we don't see the address right now. So this has been, so we notified our observers. Yeah, oh, but what we are missing here is, of course, the model doesn't know that our view observes it. So we have to say add observer this. Okay, and since our view implements an observer, this makes total sense. Okay, let's try that again. Okay, we see that's not particularly nice, but we do get an output for the addresses. It updates itself automatically, and it's very nice that it's that disconnected from each other. Yeah, so the model doesn't know that there is a view. Yeah, it still knows how to notify this view through this observer mechanism. So one cool thing here is, for example, that we could then say, well, let's have a second view. Let's call this view 2, and this one is only providing output, so all of this is gone. And let's just say in main that we have the second view as well. And it operates on the same model. And yeah, and this has to be view 2. Okay, let's rerun that. Okay, so now we actually see two windows here, because we instantiated two views. If I write something here, it also updates the other one automatically. Not much work done. This is really the power of this model view control framework. Okay, and I would say this was the first part, writing our GUI. Let's now switch to the second part, and the second part is address parsing. Okay, now in this second part of the lecture, we're actually going to talk a little bit about how to parse addresses using regular expressions. And to get a first idea of what we want to achieve, let's write some unit tests that also make clear how we assume that this address.java, this address class interacts with other components. So to create some tests, what we need to do is first create a new directory to split up source and test code, call it test, and then we go to mark directory as test source root. Now we actually can create some tests, and they are automatically stored in this directory. So we go to address and say create test. I'm going to use JUnit4 for this discussion. And I'm going to add JUnit4 to the class path I'm using. I'm going to use the one that is provided with IntelliJ. Okay, so in class, many people were a bit unsure about how to write unit tests. We're using JUnit, so we're going to do this a bit slower now. So what JUnit is going to do, it goes through these, when we run a test, it goes through the class and looks for methods that are annotated using a add test annotation. Something like that. And then it's public void and, for example, test street, and city input. Like that. And then when we run a test, this method is going to be called. Now in a unit test, we test a certain method, and what we want to test is the parse method of address.java. So we provide some input, and let's see, let's take the address of ITU, as an input, like that. And let's make that a bit nicer. Let's say that's the input. Now we test our method by calling it. So we produce an address by calling address.parse. So the parse method is what we're going to test, and we call it with the input. Okay, and now the actual unit test asserts that this address object that is created acts in the way that we expect it to do. And we assert that by calling assert true, assert false, or assert equals. So here, oops. So in our case, we say assert equals, and then there is two parameters, expected and actual. So expected is that the street is read Langors by, and the actual behavior is whatever a.street says, and so on. The house number is 7, and that should be the output of a.street. No, a.house. Then we assert equals that the postcode is correctly passed. And we assert equals that the city name is correctly passed. And then that constitutes one unit test. So there is a method that is called. We call address.parse. That is what we want to check. And then we assert that what we get from A is what we expect it to be. Now we can add some other tests here. So let's, for example, say we only input a street. And let's make that differently. Let's say this is Langale Route 27. Then the street is Langale, and the house here is 27. Okay, and we could think of doing the same with just a city and a postcode. Like that. Then we expect the city to be valuable and the postcode to be 2500. Now those are very positive tests. So this is really something that our application should achieve at the end, our address parser. Let's make a slightly more difficult test, street city input, where the input is kind of malformed. So there are some problems here like that, some spaces added here, 3 commas there, some spaces added here. And of course the hope is that our address parser is still going to parse this address correctly. And then there are also some other inputs here, and they should be invalid. So we test an invalid input 1. The naming is not as good as it can be. It's hard to describe like what's the problem with this input. Let's say somebody gives you test 12, test 12. Yeah, test 12. This could be a street, but another added test 12. This is really there's no postcode here. This doesn't remind us of an address. So what we basically want to do is that the address parser should say, well, this is not an address. And if we look at this address, there is no way of saying this is kind of invalid. So what we do is we want to throw an exception here. So in this case, whenever we don't know what to do, we want to throw a new exception. And I think a good exception to throw here is an illegal argument exception, because it basically says that the address that the string provided couldn't be parsed. So we do it like this. Okay, at the moment this is always thrown. Now how can we check that this exception is thrown? We check it by annotating the test annotation here. So we can also say what is expected. Is that there's an invalid argument exception. So we expect this to happen. I'd say we expect this to happen in other cases as well. For example, let's look at this input. Yeah, this could almost be true. This could be a street, house number, but this is not a postcode in Denmark because they're all 4 digits. Let's say there is something that looks really nice, like this, where there is actually a postcode, but then the question is, what is this 12 test 12 here? And that's how we provide some unit tests to our program. Let's see how far we got with our address parsing. So let's run all these tests. We go to test and run our tests. And we see that actually all of them fail because, it's not invalid, it's illegal. But actually I think this is the correct. So let's say get an invalid argument exception. Oh, okay, but this is used differently currently. Let's go back to the illegal argument exception. Let's change those to illegal argument. Okay, let's rerun our tests. Here we see some progress. We have 3 running unit tests. Those over here, and of course the real unit tests, what we're really interested in, doesn't work so far because, well, it always throws an exception. Okay, so now let's think about parsing these addresses. So the tool we are going to use here is called regular expressions. So I just want to give you a small introduction to regular expressions. There's this really nice website called Regex101.com where you can try out regular expressions, and it actually really helps to understand like these regular expressions. So let's go through that. Let's start with an example string. Like this is an example. Up here, there's the regular expression we want to include, and what you do with a regular expression, you always ask, does this regular expression match a given test string? Okay, and what can you write as a regular expression? Well, you can write all the characters, for example, on your keyboard here, and that regular expression is going to behave exactly as you think it would be. So the regular expression n checks for is there an n in the test string. Here it is at this position. Does this test string contain example? Yes, it does. Does it contain uppercase example? No, it doesn't. So this is case sensitive. You can also add case insensitivity by saying, well, this is case insensitive. Okay, but this is an option that you later have to set in your regular expression engine. And just to make sure, so we are going to work with this web tool here, but then we can produce Java code that has the same behavior as what we now do in this web application. Okay, so what else can we type in? We can type in, and we are now going to this quick reference down here, we can type in a single character. So we can ask, is there an A, B, or C in there? And there are 2 A's. Is there A, B, C, D, E? And there are 2 A's and 2 E's. Those match agree. But note, this is very different to this string. This checks is the literal string A, B, C, D, E in there. Okay, so this is a single character. You can also ask, which characters are not ABCD, and you get matches on all the other characters down here, but you don't get them for A and E. Okay, let's continue. So there's A to C. So over here we can, for example, abbreviate this one by just providing this as a range. Okay, so this is equivalent to ABCD. Those are single characters. Now for some of these groups of characters there are some shortcuts. So for example there is a dot. A dot matches an arbitrary character. Yeah, so it matches any character as shown here. And then there are some special backslash commands, like there is \s, which provides white space characters, blanks, and the uppercase version always provides the inverted result, so non-blanks. Here there is W. This is a word character, and as you can see, those are the characters, but also numbers are included, and the underscore. And there are non-words. Those are the sub spaces here, and this punctuation. Okay, there's digit. We don't have digits. Let's add some digits like that. Then we match these digits over here. Okay, and there is the option. What are subspace? What is a white space or a digit here? Matches those white spaces and those digits here with the respective white space. Okay, so those are, everything here is single characters. So now let's start with these here, and let's leave the exclamation mark out first. Let's start with the star and with the plus. So what can we ask of this string? We can, for example, ask, is there an A, which is then followed by any character, any number of times, which is then ended by an E. So this matches the A character, then matches any character, but 0 to unlimited times, and then an E. So is there something that starts with an A and ends with an E, and in the middle has 0 more symbols in there? We get this match here. What you can see is this is maybe a bit odd for you, because there's also starting A, ending E here, starting A, ending E here, but our regular expression only finds this one example. So the answer is here in this greedy version. So these characters here always want to pass as many symbols as they can. To make operations non-greedy, you add an exclamation mark, like this. Then we get these 2 hits over here. And we see that this one is now lazy. Okay, we can also ask, for example, is there something that has an M, any kind of character, and then a P? You see this being true here, MP. If we now were to change the star to a plus, there would be no hit, because the plus one is that at least one match is there. There must be at least one character in the middle. That's the difference between plus and the star. Now there's a hit, now there isn't. Okay, we can also say exactly 3 of a symbol, so we provide a symbol. So we can, for example, say, is there M, is there P? Now, let's say, is there A, and is there an A1? No. And is there an E? And are there exactly exactly two symbols in the middle? So this matches this string, because there's A, E, 2 symbols in the middle, N and white space. You can ask the same with 3. This would then be MPL. You can also say 2 or 3, and this is actually a range. Yeah, so if we, for example, ask for a digit, like this, and we say 2 to 4 characters, No, 2 to 4 characters. Then this is a 3 character string, this is a 4 character string, matches between 2 and 4. So note this difference here. Now there is a comma separating these two numbers. Okay. So we can also say something about 0 or 1 of A. So this is the question mark, but this will become a bit handy. This will become handy a bit later, so let's skip that for now. I hope now that regular expressions are somewhat clear, at least in what they do. Let's talk about parsing addresses. And we go back to our example. The example is over here. And we plug it in here, like that. Okay. We already see something like this digit and then 2 to 4 characters. This is actually pretty handy here, especially if we were to say, let's say, is there a 4 character digit in there? Because that would exactly mean is there a postcode hidden in there. How can we later use the result? Because in our address parser we want to say that is the postcode of our address. This is done by adding a capture group, capturing those irregular expression or sub-expression in parentheses. So now you see group 1 matches 2300. But actually, it's much more useful to give them a name, and the notation is question mark, and then the name we want to choose in these angle brackets. This is supposed to be the postcode. Then you see there's a group postcode, that's 2300. That's pretty useful already. So let's start to build up a regular expression for exactly that type of address. We're going to leave out like the floor and side things in the remaining minutes, and in the for this tutorial, for this presentation, and we are also going to focus on these well-formatted addresses. Let's see. So there's a postcode. After that, we see the actual city. And I think we should impose, it should be postcode and city next. So how can we, what is the city name? We see there can be a white space in there. But what shouldn't, what makes a city, or how do we check for a city? Well, we see it should contain all these characters. It might contain white space. So how can we say that? So the characters we want to find are A to Z, and then a lot of all the special characters, Danish, like that, and also the uppercase version. And there could also be a space in there. And what we want to see this, what we want to do, if we look at what this matches, it's already a K here, so it's a single character. It should be 1 or more characters. This should be the city. And let's call this city. Now we see down here, the postcode is 2300 and the city is actually København S. Okay, let's build forward or build it backwards. Then there was this comma, and there is a street house. The house number is going to be a digit, at most 1. It could be many, so this should also be matched, and this should be 72 as the actual number, so that's why we need this plus here. We see group house is 72, postcode 2300, city is København S. And then everything before that, if it contains only of characters or a white space, then this is actually the street. And in our version, we basically treat a street and a city pretty much the same, because it's pretty difficult to say, is this a street name or is this a city name? Only if you have access to a list of street and city names, you could check whether this is actually city or street. And with regard to that, in the assignment, you are allowed, you can, for example, do an autocomplete for street names and city names, and you get a list of all streets and cities in Denmark. And what you, for example, see, and what a problem is going to be of our address parser is there are actually streets that contain a ordinal number, like this. Okay, but let's say this is fair. This is fair enough for our purposes. There's street, house, postcode, city. We see down here these groups. Perfect. Let's see what else we want to do. So if we look at the malformed input, we see people could get the idea of providing an input like that. And we should still be able to pass that one. So let's include that and see where we don't pass it. So first of all, there are these 3 commas here. And I think it's not a question of 1 comma or more commata, but it's like, so this is a bit harsh. So we can say there might be a comma. We don't know how often it's going to occur. It's going to be like this. And then we match this query, but we also match it over here, and the result actually stays the same. Cool. Then what we see is there are these spaces here, which are actually part of the city, because we say there must be a single white space, and then there must be a single white space, and then comes the city, and that can include a white space, and those are the white spaces that we see here. So what we actually should say is that there should be a city. Let's say there should be white spaces here, at least one, to split up postcode and city name. Okay. Another problem is that we see is with the street name, because here there are actually also too many spaces that are actually matched to the street. What we would like to do is we say, well, house and street are separated by white spaces. But what we see here doesn't solve our problem, because it still matches these white spaces. You see that here. Why does it match the white space? Because if we look to the street group, that one is greedy. So it takes as many characters as it can get. And that's why it matches these white spaces as well. We can make it lazy. Then it's going to match only this part. And we see it here, no white space there. The same could of course happen down here. With that part. Okay, but here we see a problem, because actually when we say this one shouldn't be greedy, then it doesn't match as much as I want to match. Yeah. So what I want is, all the subspaces that come next should be matched to this one. Okay, yeah. Okay, this is actually a special case. I think we didn't have this in class. It's like, of course, this regular expression only can match a subpart of the whole expression. Yeah, so this is why this regular expression just decides to end here and say, well, that's how far I got, and I matched the query. So what you can also say, and this is what we have down here, is that should be the end of the string, and that should be the start of the string. So we say it should be like this. So it should, at the end, there are maybe some white spaces, but then the string should end. And in the beginning, there could also be some white spaces that we want to avoid. So if somebody would say like this, it should also match correctly. Okay, and I think this is already a pretty decent and robust version for regular expression. How do we use it in Java? There's a common way to use these regular expressions. You can also see them when you generate code from here. Then you would see how you can use it. We are going to do that ourselves. So let's go back to IntelliJ and now do the actual address parsing. So we have this string, and we get this string from our web application. And let's remove this finally. So this is the regular expression that we want to use. And then from this regular expression, you first create a pattern by calling pattern.compile on the provided regular expression. Then a pattern can create a matcher for the string s. So there is a matcher, which comes from the pattern that matches our input string s. This is what we provide. And then we can ask if matcher.matches. Okay, and if it matches, then we know it actually matches this. Regular expression. And now we can actually access the individual parts of the string, of the matched string. So now we do this is exactly by using the group name. And now we have this builder b here, up here, so we can say b dot, and then let's say we start with the street. So the street is whatever the matcher says is in group street. And by using this builder pattern, we see that we can easily chain these methods together. And this is how it's usually used in a builder pattern. Okay, next comes the house. Matcher.group house. Next comes the postcode. We provided whatever the matcher said would be postcode. And last of all, the city. And implementing the floor and site function, that's something that you can do. Try it on. Okay, let's make this a bit more easier to read. Okay. And this is how we build our, no, this is not. Okay, this would return a builder object, and we can build our address from that. Okay, let's give our tests a go. And we see streets at the input. That works. Even the malformed input, but that's what we tested again, works. City input and street input, that doesn't work yet. Okay, why doesn't it work? Well, because it doesn't follow our scheme, because here we miss a postcode and city, and down here we miss a street and house number. And now I want to come back to one little detail, and that is a question mark that is not used in either this form to make an operation lazy or in this form to give a name to a group. And that is, we can also use the question mark to say, and this is something that you can find here as well, you can use the question mark to say 0 or 1 off. And just for the sake of this very first prototype of the address parser, we say, well, we don't really know what's going on here. Maybe the user wants to provide this part, the street and house part. Maybe it doesn't. And that's why we add this question mark here at the end. Yeah, I also see this is currently a bit difficult because between the house number and the comma, we don't allow white spaces. But I think we should. And then we can do the same thing with the postcode. We can say postcode and city. This doesn't have to be the given. Let's see. All of them pass, but of course this is not very robust. Yeah, I would suggest that in terms of your own handling, you would try to split up this regular expression into subregular expression. This is how we see a street, a house, a postcode, and a city, and then you build together certain things that you want to pass, that you want to be parsed correctly. Like for example, a street is given postcode and then a city. Yeah, and then you just have multiple regular expressions, and for each regular expression, you can write something like that. Okay, so one last thing is that this is going to produce a very odd match as well. So let's also say invalid input, invalid empty input. Let's for example say the user provides this address. This really shouldn't be an address. But as you can see, this one didn't work through. So one failed because we expected an illegal argument exception, but actually was passed correctly. Because this regex here matches actually a sequence of white spaces. Okay, so that's also something for you to fix. Okay, but before we can have a look in our application, so let's go back to our application. We have to fix something. Oh, this is actually an invalid address because, and we also see like the error handler management is not perfect at the moment. It's something like this. What we see here is that the address still doesn't have a toString method. Let's add a toString method to that one. Public toString. And here we just say, well, if street is set, it's not null, then we want to output street plus white space, otherwise just return an empty string. Then we concatenate that. Oops. Sorry. And we concatenate okay. Together, so this is not street, but this is house. This is not street, this should be floor. This is not street, this should be site. This is not street, this should be postcode. And this should be the city. Like that. Okay, now if I say we actually get some output here. If I say something illegal like 12, then it's going to crash with an illegal argument exception. It's not going to crash. Yeah, so you can still do something like this as well, because everything runs in its own thread here. Okay, but so you're also invited to add some error handling here, because this address.parse could give you an illegal argument exception. But I hope this helped you to understand like what you then saw on GitHub. I think it's not the exact same version I now came up with, but I think it's very close to that one, and I hope this helped you a lot in understanding what's going on. Thank you very much.